All right, so this is constructing geometric sequences. So we have, identified geometric sequences where if you look at a sequence of numbers and it turns out that you're multiplying by the same number to move forward each time, that's a geometric sequence where they have the common ratio between any two consecutive terms. And so today we're going to look at how we can construct them, which means these learning goals here. All right, so I can write a geometric sequence with a recursive rule. I can write a geometric sequence with an explicit rule. So there's two types of rules, two formulas for the two types, and we're going to be able to write them out using those formulas that I shared with you on that graphic organizer yesterday, which is also in this lesson. Okay, so it goes with 15.2 EQ. How do you write a geometric sequence? This is what we're going to be able to do at the end of today, we hope. All right, so this is a warm-up question. And, back when we learned about arithmetic sequences, if you remember, we already learned about arithmetic sequences. We learned about recursive rules and explicit rules. All right, and there's something special that's different between recursive and explicit. Recursive has something very particular about it. So if Yusuf was asked to write a recursive rule for a sequence, which of the following is an appropriate answer? And you have choices A, B, C, D, and E. There's actually two answers that would work because they have what makes a recursive rule a recursive rule. There's something special about it. That's two of these are recursive, three of them are explicit. So you just have to pick one that's recursive. And if you're not really sure what that was, you can look back in your notes for arithmetic sequences. You can also just look at these and try to figure out how maybe two of them are unique in terms of the other three, how they're different. And I have 7 of 18 responses. Okay, so I'm going to give you another minute. You need to pick a response. Pick a response. Let's put on a timer for a minute. 1 minute. Alexa, play.
Stuck with you, stuck with you, stuck with you. Jason. Jason's here. Get jazzy on. I'm that type that you get on. International. First class seat on my lap, girl. Body comfortable. Cause I know what that girl you need. New York to Haiti. I got next stamps on my passport. Make it hard to leave.
Alexa, pause. Okay, minutes up. 15 out of 20 of you responded. Thank you. I'm kind of going through our Go Guardian right now at this point in time, and you don't have Pear Deck open. I'm asking you, like, hey, where is Pear Deck? And you have it open. You need to have the lesson open, and you need to have the meet open. You got to have both those things going. Let's see, who else do I need to send a message to? Steven. I gotta send like 7, 8 messages. Now you may have it open on a different device. Okay, just write me back and tell me that. Okay, because I can only see your Chromebook and I can only see what tabs you have and which one you're currently on. So, okay, cool. Thanks. So someone already ran it back. I'm already on it. I'll say thanks. And that's it. Just reminding you, you need to be logged in. So let's see, what did we come up with? There are 2 correct answers for recursive rules. Well, I am happy about this. Let's do some confetti. Yay. The 2 that you picked the most are the 2 correct ones. Okay, so B and C. B and C are correct. And the reason why is for a recursive rule to be a recursive rule, we have to have f of 1 defined, or if we're using the terms a sub n, a sub 1 defined. These are all in terms of functions. So for B, right here, you can see f of 1 equals 555. We're given f of 1. You have to have f of 1 when it's recursive. You have to know the first term. And for C, they do the same thing. F of 1 is here, 36. Another thing recursive rules have is that inside of the rule, so whatever's on the right-hand side of the equal sign, like for C here, you would have f of n minus 1. So you would have the one, you have the function of the value before it. So f of n minus 1 is here, f of n minus 1 is here, f of n minus 1 is here, but they don't tell us f of 1, so it's not D. So D is a little tricky. So it was either B or C. Good job. I'm glad we remember some of this stuff. Okay, here we go. So vocabulary, this is not new vocabulary. This is just reviewing the vocabulary that I already gave you on Monday. Geometric sequence is the ratio of successive terms is constant. That's what it means. So if you have a sequence of numbers and you take any 2 that are next to each other and you divide, you get the same ratio every single time. And that ratio is called the common ratio, written as little r. You can even ask yourself, what are you multiplying by to get to the next term? And so the 2 rules that we have are explicit, and this is the one we were working with already. When we were working with this on Monday, it was in terms of a sub n instead of f of n. But it's basically the same thing. This just means a function of n. But it's at the term number n is still the same. So a sub n, a sub 4 means the 4th term in the sequence, the 4th number that shows up. F of n means if this was 4, well, what is the value of the function at 4, the 4th term in the sequence? They mean the same thing, but sometimes they're written differently. So explicit rule is f of n equals the function at 1. So what is the first value in the sequence, f of 1? And then you multiply it by the common ratio to the power of that term number minus 1. Now this is the new one we haven't seen yet, recursive rule. So we have to be given f of 1. We have to just know what it is. So if we can see it, it's the first term in the sequence. And f of n is then equal to the function of n minus 1. Okay, so what the function value is previous, the term before, the one we're trying to find, multiplied by the ratio. And this should make sense because it's basically saying this question. So this question here, what are you multiplying by to get to the next term? What do you multiply the previous term by so you get the next term? And so if I'm trying to find a term, then I look at the one before it and I multiply it by the ratio. Okay. Here's that graphic organizer I shared with you. Okay, so this is the stuff we're on this week, geometric, right? There's the recursive formula. This time it's in terms of a sub n. Okay, so the whatever term, the nth term, right here, a sub n equals the term you want. It's equal to the ratio, the common ratio, r, times a sub n minus 1. So it's the same thing, but notice that sometimes they write it differently. Here they take f of n minus 1 and r, and they actually reverse the order here. Okay, they put r first, and then they put the term before, is what that means. So it's the same thing, just a little bit different. And then a sub n for the explicit formula. This is the one we're already using. So if you know the first term, then you times it by r to the n minus 1. Now recursive, you do have to know the first value in the sequence. okay? So you have to include that as well. I don't know why it doesn't write it here, but a sub 1 is the first term. So you would have to know that in order to write out this entirely, okay? Here we go. So this one we're going to do together. We'll do a couple of these together, and then you're going to try one. Now, all of these you're able to draw on. So what I suggest you do is have the two windows that you need right now, which is our Google Meet and the Pear Deck. Have them in their own window on your screen side by side. So that way you don't miss anything. As I'm showing you how to do it on one side, you're copying it down on your side. That makes sense? Anyone want to see how you pull windows out of an existing window and create your own little windows? Do we know how to do that? I've showed you before, but maybe we forgot. All right, so the way you do that is, so right now I'm projecting to you my entire screen, one of them. And so I'm a student, and this is the one that's my Pear Deck tab that I want to have open all the time. So what I'm going to do is grab the tab and just click and drag it down, and it's going to pop it out. And then when I let go, it tends to maximize. So I'm going to come over here, and I'm going to click this Restore button, and then it makes it something that I could work with. So I could resize it, and then I can move it around. And then the other thing I want to open is our Meet, right? And so I can do the same thing and just have it over here. It's going to be weird. You know how this is. It's going to start doing weird stuff. So here's where you can see everything that I'm doing, and here's where you're doing all your work. You have them both open at the same time. All right, that's what I suggest you do. If you don't want to do that, you can always just toggle back and forth a bunch of times, but that does get kind of, I don't know, annoying because you don't know if you're missing something. So we're going to do this slide together. For each geometric sequence, write a recursive rule by finding the common ratio, by calculating the ratio of consecutive terms. We've done that before. We've calculated the common ratio. And we're going to write an explicit rule for the sequence by writing each term as the product of the first term and a power of the common ratio. So I did a little screenshot here from the graphic organizer, okay? Because I use this version with a sub n, because the way that our information is given to us is in a table where n, okay, this is the term number, first term, second term, third term, fourth term, fifth term. A sub n is the actual term of the sequence. So the first term of the sequence is 2, then 6, then 18, then 54, then 162. All right, and so, you know, for both of these rules, it's a good thing to start with. Just figure out what's the first term in the sequence and label it, okay? In this case, we're using a sub 1, okay? It's also f of 1, same thing. But the way you get that one is you look at where n is 1, and then that is the first value. I really don't like how thick that was, so I'm gonna change this. It always likes defaults to like the thickest pen size ever, and so you have to change it over here with your sizer. So at n equals 1, my first term in the sequence is just 2. Okay, and now the common ratio. So I can pick any two consecutive numbers. I could pick these two and divide 162 by 54. It's a little tough to do, right? I already know it's a geometric sequence because it tells me so. So I'm not trying to figure out if it is one. I could divide these numbers. That's a little bit easier, right? 18 divided by 6. What's 18 divided by 6? Yeah, 3. Okay, so my common ratio is 3. I could even divide these two numbers, 6 and 2. That'd be the easiest one. Okay, but basically common ratio is 3 because I'm multiplying by 3 to move forward in the sequence each time. Right? So when you're starting to write and construct rules, figure out what's your first term, figure out the common ratio for geometric sequences. Now our recursive rule. Okay, so we're going to write this. Recursive is the one where we like to know what is f of 1 first. So I don't know if I'm going to be able to write it with the text tool. I'm going to have to use the pencil. Yeah, because there's like weird subscript things. So anyhow, we're going to do the recursive rule. So we want to start, when it's a recursive rule, we have to define the first term in the sequence. And we did that. We know it's this. A sub 1 is 2. So I'm going to write that. A sub 1 equals 2. All right, so that's the first thing you have to do. And second thing is the general form. So a sub n. And when I say sub n, it means it's a little n. That's sub n. And then we're using this rule up here. So all we got to do is multiply the ratio, the common ratio, r, which is 3, by the term a sub n minus 1, because that's what we see here. Okay. Now, there's a third part, and even though it's not here in this, we always want to define a sub 1, but we also want to say that this is for n greater than or equal to 2. Okay, because if n is 1, I'm not going to use this rule, because if n is 1, well, that means a sub 1, it's 2, it's defined. So this is for n is greater than or equal to 2. And that's our recursive rule. Okay, we're going to do explicit rule now. Explicit rule. We've done this one. This is the one we were doing on Monday. Okay, and so that's this rule here. And we're going to come over here and do a sub n is equal to, well, a sub 1, we know it's the number 2 times, and then r to the power of n minus 1. So r, instead of just writing the letter r, we're going to put what r is. It's 3. And this is to n minus 1. That one's a little shorter, right? So we did our recursive rule and our explicit rule. And so this is an example where our geometric sequence, okay, the actual sequence is, so our actual geometric sequence, you know, if I just had it listed out as a bunch of numbers, it's 2, 6, 18, 54, 162. It's these numbers in this order. And so these numbers are getting bigger as we go to the right. They're increasing. This is an increasing sequence. We're going to see what happens when it's a decreasing sequence. This is an increasing sequence, and our common ratio was 3. It was larger than 1. Okay, so when your common ratio is larger than 1, you have an increasing sequence. I'm going to type that because I can't even talk. This is an increasing sequence. Okay, there we go. So this is an increasing sequence. R is greater than 1. R was 3. And so we're going to go to the next slide now. And so you guys are just copying along with me. This is going to be in the video. So if you don't have this all copied down yet, you'll be able to get it by watching the video. But we're going to go to the next slide here. We're going to go to slide 6. And now our geometric sequence. Okay, I'm just going to talk about the same thing I just showed you guys. So our geometric sequence here, it goes 10, and then it goes 3, and it goes 0.9, and then 0.27, and 0.081. Okay, this sequence is decreasing. Okay, that means R is going to be greater than 0. Oops. R is greater than 0, and R is less than 1. We'll see that. We'll see that as we figure it out. So the sequence is decreasing. It's getting smaller as we go to the right. So this value of R, if we do this correctly, it should be a value between 0 and 1. And you just get the common ratio. So you pick any two, you know, I mean, for me, since I know it's already geometric, I'm going to pick the easiest two, which is going to be the first two. I'm going to take these two terms and thus set up my ratio. 3/10. There we go. 3/10. I mean, that's the same as 0.3. It's not 0.3 repeating. That would be 1/3. This is 3/10. A little different. And this is just showing you this number here is bigger than 0 and it's less than 1. So I know I'm doing this correctly. That's what we're multiplying by each time as we move forward. 3/10. And then our first value in the sequence, a sub 1. Okay. If I want to know when a sub 1, that means a sub n is 1. Okay, right here, it's 10. Did I lose anybody? I mean, I know stuff it can get complicated. So like ask questions if you're not quite understanding. I have a message in my chat. Code for Pear Deck, BCIUVR. BCIUVR. Somebody asked for the code. That was the question. All right. So I'll go back to my screen here. So we're going to write a recursive rule and an explicit rule. The recursive rule, two things that are always true, even though it doesn't say it here. You have to say what a sub 1 is. And you also have to say that this is true for n is greater than or equal to 2. Whoa, that was weird. Undo. 2. And so over here, when I do my recursive rule, we're going to say what a sub 1 is. What is a sub 1? How about someone put it in the chat? Kobe's right, okay? I'm basically asking you, what is the first term in the sequence? It's 10. 10. And then we're going to use this formula. So a sub n is equal to, and we're going to multiply the common ratio with a sub n minus 1. What is the common ratio? What is the common ratio of our sequence? Thanks, Kobe. So it's what we figured out here. R is the common ratio. We could either say 3/10 or we could say 0.3, 3/10. You read both of these, the fraction and the decimal, the same way, 3/10, 3/10. And so we're going to write here 3/10. You could either put 0.3 or you could put 3/10, up to you. 3/10. And then I'm going to multiply that by a sub n minus 1. It's a weird a. A sub n minus 1. Sorry that this is me writing with a mouse. It's not beautiful, but those are multiplied. That looks like 0 times 3. Maybe I'll change this to the fraction so it'll look a little more different. So I'm just going to change it to 3 over 10 times a sub n minus 1. And then I'm also going to add in at the end for n is greater than or equal to 2. All right, that's the recursive rule. Now the explicit rule. Right here, it's this guy. So the only thing we replace on the explicit one is you replace what a sub 1 is, and you replace what r is. A sub 1 is 10, r is 3/10 or 3/10. But you leave the other parts of the formula there. So a sub n equal to a sub 1, so 10 times r, or 3/10. And this is 2 the power of n minus 1. You can also put the decimal in the parentheses if you want. Okay. So I'm gonna let you guys try one of these slides now, and see how you do on it. I'm gonna give you like 4 minutes to do as much as you can on a slide just like this, like we just did. And the one that I'm gonna give you is actually a little bit, it's a increasing sequence, okay? So a sub 1, you're gonna figure out what's the first term in the sequence. R, what is the common ratio, okay? If you divide 2 consecutive terms, what do you get? Because it's an increasing sequence, it should be a number bigger than 1. And then with those 2 values, you're going to write a recursive rule and explicit rule. So I'm going to give you 4 minutes to do this. Alexa, play. Alexa, next. Alexa, next. Alexa, volume 4. Alexa, volume 4.
All the folks down in Lynchburg, Tennessee.
Alexa, next. Alexa, next. Okay, so you guys, we are moving through our time really quickly here. A sub 1 is 5, and the common ratio is 4. That's good. And I don't really know the rest, to be honest. Okay. 5, first term, 4 is the ratio. Recursive rule is A sub 1 is 5. Good. And then you want to write, I'm not really sure what that says. This one looks a little bit maybe easier to read. 4 times to the n minus 1. This one's right. So this is the explicit rule here. I know it's hard. You can't do like a sub with the text, so you kind of have to draw it with your writing tool. Okay. So it looks like you guys, if you tried it, you were getting A sub 1 and what the common ratio is. And then it's just plugging in to figure out the rule. All right. So coming back here, we have 2 minutes. Wow. Okay. So we figured out A sub 1 and the ratio. The recursive rule, though, so A sub 1 here is 5, the common ratio is 4, and then your recursive rule, so we want to say that A sub 1 is 5, okay, and then we would say A sub n is equal to, you put the r here next because that's what comes next, 4 times A sub n minus 1. And then for the explicit rule, for n is greater than or equal to 2. For the explicit rule, we start with A sub n, and then we replace A sub 1 with what it is, which is 5 times 4, that's the common ratio, to the power of n minus 1. Okay, I'm going to end the notes right here. There's more slides, but we don't have enough time to get to them. And so, let's see. Try the HMH assignment. I'm going to show you how to do that. So how about this? Since we are going to have a 5-minute break, technically, I'll show you how to get into HMH during our asynchronous time, but go ahead and take your 5-minute break. So we'll start this at 1:50. So I'll put up a 5-minute timer, and then I'll show you how to do constructing geometric sequences.